Hello everybody and welcome to another video. Happy Thanksgiving, by the way. I said I was going to do this over the break and then I kind of forgot to. If you can hear, I'm somewhat sick, so that'll be my excuse. But I'm going to do it anyway, so here you go. Parallel lines and stuff. Yippee. Look at those. Look at those parallel lines. Yay! Alright, let's get to it. So you're going to look at this diagram and you're going to be like, whoa, that's a lot of angles. What's going on with all these? And then you get all these letters too, and you're like, hey, that's a lot of angles and a lot of letters. But I think the most important part right now is just understanding what each one of these letters means. I think the easiest one for now is just to say, hey, the P in all these is for parallel. And that's pretty straightforward. The thing that you're going to just have to remember for later is that if the P is in front, you already know it, and if the P is at the end, you don't know it yet. It's kind of just like in chronological order. So if you already know it, then it's in the front, and then if you don't know it yet, it would be at the end. So this would be AIP. But for right now, let me just clear this off, rewrite that parallel. The next one is A, and C really, but C is a little bit weird. The next one is A for alternate. Now what does that mean? Alternate means that, here's your transversal here, alternate means that it's just going to be on the other side. So like 1, 3, 5, and 7 are alternate to 2, 4, 6, and 8. So basically, sorry, I need to find a better way to do this. I always have to clear it all. Whoa, that was crazy. Still messing with my system here. Anyway, so if you were to say that, like, what angle is alternate from 1, you could say 2, 4, 6, or 8. All of these are alternate from 1 because, you know, they're, like, on the other side of the transversal. Like, if you think of things that are alternating, you got, like, A, B, A, B. They're not the same. They're, like, changing. So you're changing the side of the transversal that's on. As for C, C has two different things, which makes it a little confusing, like which C are we talking about? This C here is the only time where this comes up. This is for consecutive. I'm just going to write consec. Consecutive just means like if you took an angle here, like if this was your angle, you just shift it down the transversal. So it would be here. It's like as easy as that. There's the thing with the letter F, which I'll talk about later, but I think the easiest way is to think like if this is your set of angles here and this is your set of angles here, you just shift it down the transversal and that'll be your next one. It's getting a little busy here, sorry. So you just have an angle here, becomes an angle there, or this angle is this angle. Those are corresponding angles here. That's what the CA stands for. The other C that you can have here is these ones. That's for consecutive. That's the opposite of our alternate. So consec. Sorry, I'm struggling to write here today. Consecutive means that they're on the same side. So 2 is consecutive to 4, consecutive to 6, consecutive to 8, but not to these ones on the other side. So if you, I don't know, just want to think about it like consecutive, instead of being A, B, A, B, it would just be A, A, A. They're all on the same side. You don't change anything. So you're not doing this. You're not going across the transversal. They're all on the same side of the transversal. I is for interior, and E is for exterior. Sorry, this is terrible handwriting, but you're listening to my voice, so ideally you'll be able to know what I'm writing. Interior and exterior, just like if you're thinking of this as the little box here, something is inside the box or something is outside the box. If you know what in and exterior mean, like in is in the box, ext is like exit, it exited the box. You can use some of your root word knowledge there, but like 3, 4, 5, 6 are all interior. 7, 8, 1, 2 are all exterior. So there you have it with this. So just real quick, if you think about this, parallel, alternate, interior. So the lines are already parallel because we know that. Alternate means that it's going to be on opposite sides, and interior means it's going to be on the same, like on the inside. So if we took 4 here, we know it's on the inside because it's an interior angle, and the only other one that's across the transversal from it is this one here. So that's parallel, alternate, interior. All these ones, by the way, just mean that it's going to be congruent. And all of these ones, this S, mean that's going to be supplementary. Really, the big idea with this is if it looks like it's congruent, then it is. Like, that's the thing with these, is they're only ever going to be congruent or sup So if you're like, hey, this one kind of looks like this one, then it is. I mean, if they're already parallel, then they're going to be. Like, this one looks like this one. They are. That's how these work. So hopefully that was helpful to you. Let's talk about the Z's and F and other word letters. Really, there's only two. But I guess if you can kind of say that the Z's turn into N's. I do like the Z trick quite a lot. This is for your PAI and AIP. Whether you know it's parallel already or not. Like if you were trying to prove these were parallel, you take your corners of your Z and you would say that these are congruent to prove it's parallel. I think this is a really nifty one because it does really show the PAI pretty well. Kind of the trick with it too is that you can do like a backwards Z. It all kind of counts as a Z. There'll be these angles here. That's also due to PAI. And then the other letter technically is F. This would be for CAP or what is that? PAC? PCA, sorry. Getting them confused here. Basically, you just take the inside of these angles. This is your corresponding angle. So like I said, if you know that it's here, you shift it down to the next like chunk of angles. So you can think of it that way. And of course, you can go the other way with your F. This could be your F, and these would be corresponding. But for me, I mean, you can do it upside down F too. They can kind of be wherever you want. These would be your corresponding angles. But for me, I just like to think of you have an angle up here, and then you're shifting it down to the next one, which would be 6. So now let's talk about parallelograms. It's like parallel lines, but now they're a shape. Isn't that creative? Anyway, let's just talk about these for a second. If you know that this is a parallelogram, which we do, this is a little symbol for parallelogram, there are so many things that you know about this shape now. Like, it's pretty crazy, actually. So if they tell you that, they're giving you big hints. First thing you know is that this side is congruent to this side, and this side is congruent to this side, which is already a pretty big thing if you're trying to do CP/CTC somewhere. These lines are parallel to each other, and these lines are parallel to each other. Also good if you're going to use any of the parallel line theorems. You know that these diagonals here are perpendicular bisectors, which means that these are all going to be 90-degree angles in here. And you know that these bisect these angles. So, and due to that, sorry, this was a bad line. Due to that, you also know that these whole angles are congruent. So D and B are congruent, and A and C are congruent. If you've noticed, it's kind of all about opposites. So you got your opposite sides, and you got your opposite angles. And then you got the weird, like, diagonal line stuff going on here, but that's kind of less important. They don't really ask many questions about that, if I'm being honest. So now, what if you want to, like, prove that it is one? Well, that gets a little bit more complicated. You got to prove any one of these things, but the trick is that there's a lot of boths and ands, and one or the other, and opposites. There's a lot of thinking that you got to do, which is unfortunate. So, starting with the first one, both pairs are parallel. So you could say that this one is parallel, and that this one is parallel. Or like, sorry, I totally messed that up, my bad. This one is parallel to this one, so these opposites are parallel, and this set of lines is also parallel. That's a parallelogram then. This is something that, like, if you had a Z here, and you knew that these angles were congruent, you could prove that it is by AIP. Then you know that these lines are parallel to each other, similar to, like, these ones. If you had this kind of Z, you can know that these ones are parallel. Anyway, that's just a tip for that. Similarly, you could know that it's a parallelogram if they're both congruent. So, like, just like that. That would mostly be like a triangle one. Like with the triangles, you know, these triangles are congruent, so you can do CP/CTC. One pair is both parallel and congruent. This one is a little difficult to think about, and I think a lot of the questions will mostly be on this one. This is like if you have this side and this side, you got to know that they're both parallel to each other. Or sorry, this is congruent and then parallel. So, I mean, there are a number of ways that this could come up, and we're going to do some proofs in a second, but, you know, you have, like, these two triangles are congruent, and then you have the PAI to say that the lines are parallel, or AIP, sorry. So that's that one. I've seen the most questions on this one, or, like, the most difficult ones on this one, so you gotta keep your eye out for it. We'll practice with that. Angles, just that both opposite angles are congruent. So this angle, and this angle, and this angle, and this angle. If that makes any sense. I mean, again, it's going to be probably a CPCTC. And then diagonals bisect each other. Doesn't happen so often, but you just got to prove that these are bisections here. So let's talk about some proofs. Obviously, I won't be able to cover every single proof in the whole entire book and what every single one that's going to be on the test, but I can do a couple. So send me in some proofs if you want me to do them with you, or let me know, or don't. I don't know. Just watch these and see what you can learn from them. Let's start with this one. Bisect, more like bisect. Alright, anyway. Given that DB bisects AC, so what we know by this is that these ones are going to be congruent, and angle 1 is congruent to angle 2. Prove that ABCD is a parallelogram. Now, you might be starting to realize at this point that there's actually a couple ways you could do this. For now, I'm just going to do the one that's the most convenient for us right now, and is the most easy to teach, and I wrote them out for myself so that I don't have to draw all these things out. My handwriting is terrible. We're going to do CPCTC, and that should kind of be like a given for you. No pun intended with given being our first step here. If you see triangles, usually CPCTC. Not all the time, but usually. The first angle that we have here is this angle 1 and angle 2, so that means that these will be our triangles. So I'll clear it off a little here. These will be our triangles. And we already have this angle here. Next thing is that we've got what I said before was this one side here. So that means we have a side and angle. And then we have these ones here due to vertical angles. This one is a little bit harder actually, because you might have forgotten that vertical angles were a thing. Because we're so busy with PAI and AIP, but you just gotta remember that they're a thing. I mean, if they're across from each other, they're congruent. So I should say these are congruent to each other. That gives us our ASA, which means that those triangles are congruent. And now let's think about this. What exactly do we want to prove here? What CPCTC do we want to prove? So we know that this and this are already congruent. What other things do we have that we could prove are congruent? Well, we could prove that this side, or this angle. What I want you to think about here is one of our proofs that we could do is the double bisection. We already have one of them. I think the easiest thing here would be to prove that these two, DE and EB, are congruent, because then we already know that this is a bisection. If these two are congruent, then that would also be a bisection. So, let me click through this here. DE and EB, like I said. ACA bisects DB because they're congruent. And then you know that it can be a parallelogram because the diagonals bisect each other. So there's that proof. Should be pretty straightforward. Let me know if you have questions about that. Let's start barking at cars. This is just, I don't know. I like it when they do this stuff with the book. Bark and car. See, get it? So, cars and isosceles with base CR. Kind of the hardest part about this is you have to remember to actually do all your steps. Like when I first did this one, I forgot to do all my steps. When you see isosceles, you should immediately be thinking that this is true. That's what you should be thinking about. But you still need to prove those things. So, and then also in this one I was just going to say, there's no actual triangles to do. Like if you look at the thing by itself, there's no triangles that look congruent. So you don't have to do anything with the ASA or whatever pleases you. You gotta remember to prove this. You can't just say that, like, you can't just ignore it and say that it's given, because it's not. It just says it's isosceles. And then this one down here, just like ignore this for now. This one down here is also true. C and R, because of the little, I don't know, I could do this hand signs, but I don't have a video camera on. You know, this type of thing. Anyway, going back to this one, you know that AR and AC are congruent, and AC is congruent to BK. If AC is congruent to BK, then you know, and you know that these ones are congruent, then you know that they're all congruent. So AR is congruent to BK because of transitive, because there's a bunch of congruencies going on here. And then same thing with angles. You know that these are congruent, and you know that these ones are congruent up here. So you can say that they're all congruent. So once you've got that, you can see that you're trying to prove that these are parallel lines here for our parallelogram proof. And if you have these angles, you can see that it's kind of like these lines on a transversal. And I already have this written out over here, but if you think about it, you're just taking this set of angles and shifting it down over here. So it becomes this. And that's consecutive. Or you can leave your F. Sorry, I don't have enough colors, but this is your F. Anyway. So that's CAP, consecutive angles parallel. And then you know that BARC over here is a parallelogram because these are congruent, which you proved up here. And you know that they're parallel, which you proved over here. So that would be the parallel and congruent. So there is that one. And this is our last one. I promise this video is getting a little long. I know you and your attention spans probably aren't going to handle this. Here's our last one. This one is a bit of a doozy. It's called kangaroo parallelogram because they're kind of like nested inside each other. I don't know. I was just making things up. It's like the little Joey. I don't know. Might be losing it. It's pretty late. What do we know here? We know that, well, first of all, we know that ABCD is a parallelogram. Remember what I was saying before, how many things that is? That means that this is congruent. That means that these are parallel, and these are parallel. That means that these whole angles are congruent, and this diagonal will bisect this angle. So all of those are things that we know, but it's getting kind of messy here. What can we applicably use here is really the question. We can use this other given as a hint. We know that AE and CF are congruent. What I'm looking at here is there are two triangles that you can do. You do this triangle or this triangle. And I actually kind of forget what I did, so let me look here. Yeah, this is the side that's given. I'm pretty sure I do, yeah. So this is BA and CD. BA and CD, we already know are congruent because of ABCD being a parallelogram. We know these are congruent. And the last thing that we're going to need is an angle in here somewhere, or the third side. Where are we going to find that third side or angle? We're going to find that using PAI. If you look at this here, sometimes it helps to draw the lines all the way out, I find, and actually look at it like the original diagram, because it helps you think of it like the original diagram. So it's kind of turned on its side here. But if you look at, this is the angle we're looking for this BAE and CFD. If you look at it here, this is your Z, which is PAI. Z is always PAI, because these lines are parallel, and they're alternate from each other, and it's on the interior. Anyway, so there's our triangles. We know that these triangles are congruent. Next, we have to decide what we want to choose exactly. We know that this and this here, and these ones are all congruent. 3 more things to choose from. What could we choose from here? I would say the most helpful thing would be these lines, this BE and FD, because this is part of the inside parallelogram, and 2 of the 5 proofs use the opposite sides being congruent, so I think that's a good place to start. Sorry, I didn't know this was in 2 steps here. So yeah, BE and FD. If you think of one more thing that we could use this angle here, and then say that because this is a straight line, that these ones would be congruent, which is due to our sub to same angles, or sub to congruent angles, really. That one's something that you kind of just have to look out for in general. Again, it's easy to forget these things that we learned a long time ago, but you can see that this is a straight line. If you know this angle is, these angles are congruent, then you know that these ones are also congruent. So now what we have most importantly anyway, is that these angles are congruent. Or these sides are congruent, sorry. These sides are congruent, and that these angles are congruent. What we want to do here now is, because it doesn't look like we're going to be able to get these sides to be congruent as well, as of right now, we're going to see if we can get these lines to be parallel. So here are your lines that want to be parallel. Here's a nice little transversal coming through here. And oh look, what do you see? You see these angles here. And what do they make? But a nice little Z. And we remember what that is? That would be AIP. Remember, because we're trying to prove that it is parallel. The parallel does not come in front. It comes in the back. So, we know that these two are parallel due to AIP. And we already knew that they were congruent from up here. Right? Wait. Yeah, up there. Wait, no. These ones. Sorry. We knew they were congruent from over here and parallel here. Which means that it is a parallelogram, because they are parallel and congruent. So, that was the end of that proof. Whew, this is getting to be a long video. Sorry this took so long, guys. I am a little bit under the weather. That will be my excuse. But I'm glad you watched, and I'm hopeful that you will do well on this following test. Thanks for watching.